Okay, financial maths. Today we are starting on the topic about that, but before we go into the new things, let's talk about what you should know already. Okay, so already you should know simple interest, simple decay, compound interest, and reducing balance. So there should be a negative. Okay, so that is formulas that you've used in grade 10, you've used it in grade 11, so it shouldn't be anything new to you. Now, going into an example of those. So this is a more advanced example, but it is a good one to keep in the back of your mind to know that they can ask you something like this. Okay, so the example is, how long must any amount of money be invested for in order for it to double in an interest rate of 8.5% per annum? Simple interest. Okay, very important, simple interest. Give your answer in years and months. Okay, so firstly, we know we need to work with simple interest, which is A is equal to P, bracket 1 plus your interest times your amount, like your years, close bracket. Now, do we have the amount? No, so we're going to make the amount X, because we don't know what's the amount. But we do know the final amount is double the initial amount. So if our initial amount is X, we double that, so it becomes 2X. So now we substitute everything into our formula that we know. Our end amount, which is 2X, X, which is our initial amount, then the 1. Okay, and then our interest, please remember it must be in decimal. Then our N is our time. So either our years, our months, our quarterly, whatever, our N. Okay, so then we want to get X separately. Well, we completely want to take it out because we currently have two unknowns. But if I divide X here and divide X on the right hand side, it cancels out. So this X cancels with this one and this one with this one. Perfect. Now I am left with 2 equals 1 plus 0,085n. To get the n separate, I'm going to take the 1 over and divide with 0,085. Then we get n is equal to 11,76. Now, to find what 0,76 is, I'm going to times 0,76 by 12 to see how many months that is. So we get that it would be 11 years and 10 months before the money doubles. Okay, so this was a quick recap of how we work with simple interest and things that you're already supposed to know. Now, for our next piece, nominal and effective interest rates. So the effective interest rate is the equivalent annual interest rate that you would receive once compounding has been taken into account. Okay, so I'm just going to straight into an example to show you how it works. Now, for example, given an interest rate of 12% per annum compounded monthly. Okay, so this, our original interest rate, we also call our nominal interest rate. Now, question A, determine the effective interest rate. And then question B, by using the effective interest rate, convert an interest rate of 12% per annum compounded monthly to an interest rate of 12% per annum compounded quarterly. So we need to change our monthly into quarterly. Firstly, our effective interest rate is 1 plus, our effective interest rate, equals bracket 1 plus our nominal interest rate, bracket, and our time. So monthly, quarterly, whichever. Okay, so now, basically, I just want to solve my effective interest rate. How I'm going to do that, I'm going to take the 1 over, it becomes minus 1, and then I just put this whole thing into my calculator. I'm going to get a decimal. Please remember to convert your interest rate back into a percentage. Good. Now, question B. By using the effective interest rate, convert an interest rate of 12% per annum compounded monthly to an interest rate of 12% per annum compounded quarterly. So now we need to change our 12, our monthly, to 4, which is quarterly. So I'm going to have, again, the exact same formula, but now already I have my effective interest rate. Again, it's back to decimals. Don't use the percentage. Okay, I'm going to have 4 instead of 12 because now I'm doing quarterly, which is 4 times a year, not monthly, which is 12 times a year. Good. Now, to get this away, I'm going to take my 1 over to that side. First, my to the power of 4, I'm going to get away by square rooting. So in this question, you can see this just moved to the left side and this moved to the right side. Okay, so root 4 to get to the power of 4 away. I take my 1 over to that side. How do I get a divide away? I times it. Now I get my nominal interest rate as 0,1212. Taking it back to our percentage is 12,12% per annum compounded quarterly. Okay, so this was a very long one, and now we're getting to what we're doing now, okay, which is a quick way. So our formula to convert from a previous, like our original interest rate to a new interest rate, we're going to use 1 plus I new, which is I new is interest rate with new compounding period, which would be M, is my new compounding period, okay, equals to 1 plus I nom, which is my nominal interest rate, which is also my original interest rate. So usually the one they give me in the question. Okay, and then N is my original compounding time. So in our previous question, our original time was monthly, so our original was 12, and our new one was quarterly, so M would have been 4. Okay, going into an example. Good. So example, convert an interest rate of 12% per annum compounded monthly to an interest rate compounded quarterly. So again, from monthly 12 to quarterly 4. Okay, substituting into my formula, I have 1 plus I new. I don't know what this is. I need to solve this. Okay, M, which is my time, is 4. Okay, please note that. Quarterly is 4. Then substitute on the other side. 1 plus my interest rate that you give me in the question, my original one, my nominal interest rate. And my time period is 12 because it's monthly. So again, I need to solve it to get my to the power of 4 way. I root 4. Then I take my 1 over to this side. How do I get a divide 4 way? I times by 4. Then this whole thing I'm going to put in a calculator. Okay, please, please, please be careful. Put it in properly. When you put it into your calculator, make sure that you put this negative 1 outside of your root. Okay, don't put it underneath here. Okay, and then I get my new interest rate as 0,1212, which is 12,12% per annum compounded quarterly. Okay, so as you can see, this is a lot shorter than we had with our previous one. It was exactly the same question, but here we had 2 steps we needed to do, whereas with the new formula and the way we're going to follow from now on, it is only 1 step. So our new interest rate, okay, so our first part, our new, anything new we want, equals to all our old ones. Okay, so our new interest rate, our new time period, our old interest rate, our old time period. Okay. Then the trick you need to remember, please, is to get any to the power of away, you root by it. So to get to the power of 4 away, you need to have root 4. And vice versa, if I needed to get to the power of 12 away, I root 12. Okay, and that is it for our first part of financial maths.